Alright, today's lesson is 6-1. Our objectives for today are to solve systems of linear equations in two variables by graphing and classify the system based on the number of solutions. Our second example, which we'll do tomorrow in class, is to solve contextual problems and interpret solutions in context. A system of linear equations is a set of two or more linear equations containing two or more variables. You don't have to write anything on this slide down. We'll tell you when to start writing. This is just a little example of what a system of linear equations would look like. It's two linear equations, so two or more. A solution of a system of linear equations is an ordered pair that will make both equations true. An example of this would be the point 2, 3. The point 2, 3 in both of the above linear equations will work. If I plug in 2 for x and 3 for y, this works out because 2 times 2 is 4 minus 1 is 3. Here, negative times 2 is negative 2 plus 5 is 3. So again, it works for both of the linear equations up here. It works for the system. So it is a solution. A graph of the system will show the solution as the point of intersection. So this is saying if I were to graph these two lines, here's my y equals negative x plus 5. Here's the line for y equals 2x minus 1. And if I graph these, they're crossing or meeting right here at the point 2, 3. So that's where I got my answer or my solution over here as being 2, 3. It's the point in where they intersect or cross.
Alright, for number 1 on your handout sheet, we're going to graph y equals negative 2x and x equals negative 1. Go ahead and write these problems down. You may recognize y equals negative 2x as a direct variation equation. It's the same thing as y equals kx or y equals mx plus b, and our b is 0. So, as with any direct variation equation, the first point we're going to make is at the 0, 0. And then our slope is this negative 2. And we can write that as a fraction, negative 2 over 1. Again, the number in front of the x is always our slope. So for negative 2 over 1, we're going to go down 2 and over 1. And then we're going to do the opposite of that and go up 2 and negative 1 or back 1. Once you have 3 points, you can go ahead and draw your line. Alright, and that's our first line graphed. Now, the next thing we're going to graph is x equals negative 1. This may seem a little bit confusing at first because there is no y and we're used to saying y equals mx plus b. So, to make this easier, go ahead and draw yourself a table with x and y. And just put negative 1, and negative 1 for x. And then your y's can be anything. So let's say y is 1, y is 2, and y is 3. So we're going to come to the negative 1 on the x and make a point at negative 1, 1. Then we're going to come to the negative 1 on the x and make a point at negative 1, 2. Negative 1 on the x and make a point at negative 1, 3. Now we have our 3 points, so we can go ahead and draw our line. Alright, now that I've graphed both the lines, I can tell what the solution is to this system of equations. This point right here, where the two lines intersect, is going to be my answer. So, I have to write that as an ordered pair. And again, the graph is not my answer, the lines are not my answer. It has to be this point where the two lines intersect. So, that is negative 1 for the x, and the y is 2. So, make sure that you have all of that written down, and now we're going to switch over to notebook paper and check our answer. You can pause the video if you need to get that down. Alright, so over here on my paper, I'm going to go ahead and rewrite the problem. Number 1 is y equals negative 2x and x equals negative 1. And now I have to check my answer. My ordered pair was negative 1, 2. So I should be able to plug in negative 1 for x and 2 for y, and every statement here should be true. So here I have y, I'm going to plug it in 2 equals negative 2 because that's part of my problem, and then a negative 1 for the x. And then over here I just have an x, so all I have to do is plug in for my x. So let's evaluate these statements. Here I have 2 equals, and then negative 2 times negative 1 gives me positive 2. Negative 1 equals negative 1. That is also true. So both of these statements are true, so this problem checks out. You need to have both the graph, the ordered pair, and the check written before you move on. You can pause the video if you need to. All right, go ahead and write down number 2 on your notebook paper because we're going to have to solve for y before we can move on to our graphs here. Number 2 is 2 over 3x minus y equals 1. And 3y equals 2x plus 9. So again, like I just said, the first thing we've got to do here is solve for y on both of these equations before we can graph our lines. So the first one, we're going to subtract 2/3 x from both sides. And then this cancels here, and over here, we're going to rewrite the problem. Negative y equals negative 2 over 3x plus 1. I write these separately because 1 and negative 2/3 x are not like terms. They cannot be combined. I write them in this order because my goal is to get it as y equals mx plus b. And I put a plus sign in front of the 1 because I know it's added because it's positive. So now I'm almost done here. All I have to do is get rid of this negative sign in front of the y. I know when there's nothing in front of a letter or variable that there's an understood 1 there. I'm going to have to divide everything in the problem by a negative 1 in order to get my y positive. It can't be negative. So our negative 1's cancel here, leaving me with y equals, it's going to change the sign here, negative 2/3 divided by negative 1 is positive 2/3 x, and 1 divided by negative 1 is negative 1. So I'm going to write that as minus 1. Over here, it's a little bit easier. I've only got one step here. I have to divide everything in the problem by 3 to get my y by itself. So that's going to cancel here, and it's going to give me y equals 2 over 3x plus 3, because 9 divided by 3 is 3. So now I have solved for y in both of these equations, here and here, and I'm ready to go to my graph sheet and write down these equations and then graph my lines. Alright, so you may already notice that these equations have something in common. This 2 over 3x is a common feature here and here, and that does mean that my lines are going to be parallel. So we're going to have to graph these lines and see exactly what that means for solving a system of equations. So for the first one, my b is negative 1, so that's going to be my first point. That's where I begin on the y-intercept. And my slope is 2 over 3, so I'm going to come up 2 over 3. 1, 2, 3. I'm going to go back to my beginning point, and I'm going to do the opposite. I'm going to go down 2 and back 3. 1, 2, 3. And now I can draw my line because I have my 3 points. Now, that's my first one. So now I have to graph the second one. I'm going to come to the 3 on the y-axis, the y-intercept. 1, 2, 3. That's my beginning point, my b in my equation. And now I'm going to move the same slope up to 1, 2 over 3. 1, 2, 3. And then I'm going to do the exact same thing, go back to my beginning point, go down 2 and back 3. And make another point. And then I'm going to get my ruler again and draw a line. Alright, so the whole goal of a system of equations is to find the point where the two lines intersect. One thing we know about parallel lines is that they are defined by two lines that never intersect. So because of that, there will never be a point where these two lines intersect with each other. So we say there is no solution because they will never cross. So when two lines are parallel, they have the same slope, different b's, different y-intercepts. There is no solution because the two lines will never cross. We also call this inconsistent. And the good news is we don't have to check this because we don't have a point to check because, again, the lines will never cross each other. So once you have this worked down and the graph, you're good to go. Write the words no solution. Show yourself that that's the final answer here, and we can move on to the next one. All right, go ahead and write this problem down on your paper for number 3. Your first equation is 2x plus 4y equals 8. And your second equation is 3x plus 6y equals 12. So again, just like the last one, the first thing we have to do here is go ahead and solve for y. So we're going to do that by subtracting 2x from both sides here. Which is going to give us, that cancels. It's going to give us 4y equals, and again, negative 2x and 8 are not like terms, they can't be combined. So I'm going to say negative 2x plus 8. I say plus 8 because my 8 is positive. I'm not done yet because I still have a 4 here in front of my y, so now I have to divide everything in the problem by 4. Those cancel. Negative 2 divided by 4 is going to give me negative 1 over 2x. It just reduces down. Plus 8 divided by 4 is 2. So that is my final answer for this equation. It is y equals negative 1/2 x plus 2. Over here, I'm going to first subtract my 3x from both sides, which is going to give me 6y equals negative 3x plus 12. Now I have to divide everything in the problem by 6. These 6's cancel here, leaving me with y equals negative 3 over 6 reduces down to negative 1 over 2, x plus 2. There's my second equation. Make sure you have all of that worked down before we look at the graph. You can pause the video if you need to get that down. All right, we've got something really interesting going on with these equations here because our first equation was y equals negative 1/2 x plus 2. And funny enough, our second equation was also y equals negative 1/2 x plus 2. So we've been graphing two lines and we have two equations here, but if you look closely, you can tell that the equations are exactly the same. So we really only have one line to graph here. So let's go ahead and graph that line and see what that means for our system of equations. We're going to go to the positive 2 on the y because that's my begin. And then our slope is negative 1/2, so we're going to come down 1 and over 2. And then again, we're going to go back to our beginning point, up 1 and back 2. Now I've got my 3 points, so I'm going to go ahead and draw my line. All right, and just so we're totally clear, if I were to graph this line, I would go to the positive 2, and then my slope is again negative 1 and 2, so it is the same exact line. What that means is that at virtually every single point, everywhere on this line, our two lines are intersecting, and that's the whole goal. The idea, the answer to the system of inequality, or the system of equations, is where the two lines intersect. So they're intersecting everywhere because they are actually the same line. So what we say for that is that there are infinitely many, I-N-F-I-N-I-T-E-L-Y, infinitely many solutions. Meaning there is literally an infinite number of solutions because everywhere on this line, these two lines are intersecting because they are the same exact line. Another word for this is consistent, dependent. We talked about how the parallel lines were inconsistent. This one is consistent, dependent, consistent or dependent. Because there are infinitely many solutions here, we don't have to check again here because whatever we check anywhere on this line, it should always come back as true. So we don't have to check because there isn't going to be one specific point where the two lines intersect. It's everywhere. So infinitely many solutions is your answer here. And once you have that down, you're ready to move on to the next one.
All right, here's number 4. Go ahead and write it down. You have 2x plus y equals 1 and y equals negative 1. Now again, before we can graph, we have to make sure that both equations are in y equals mx plus b. Okay, so for this first one, we need to get the x to the other side, so I'm going to subtract 2x from both sides and say y equals negative 2x plus 1. Again, I can't say 1 minus 2 because that 1 does not have an x with it and the 2 does. Okay. So now we have that one in y equals mx plus b, so we're ready to graph with that one. Now this other one doesn't have an x, so we can't get it in y equals mx plus b, so we're just going to make a little table like we did when we had the one that was x equals to a number. This is kind of the same kind of deal. When I make my table, y equals negative 1 no matter what, so all the way down the y column, I'm going to put a negative 1. And then I can pick whatever I want to for the x. So I'm going to pick negative 1, 0, and 1. Okay, so now I'm ready to graph, so we're going to switch over to the graph paper. I'm going to write my equations over here so I remember what they are. Y equals negative 2x plus 1. And then y equals negative 1. So for this first one, my b is 1. So on the y-axis, I'm going to find the 1 and put a dot there. And then I can put this negative 2 over 1 for my slope. The top number is my rise. The bottom number is my run. So it's negative 2 over 1. So I'm going to go down 2 and right 1. Or up 2 and left 1. And again, since the number in front of the x is negative, I need to make sure that left to right these points are going down, and they are. That'll help if you just take a second and check that. And I'm going to get my ruler and draw my line. Actually, I'm going to go ahead and go down 2 more and write 1 more just so that I have a really good line here. So there's my line for y equals negative 2x plus 1. And then I'm going to look back at my chart with my points for my y equals negative 1. I have negative 1, negative 1, so I'm going to go left 1 and down 1. So I went left 1 and down 1, then I'm not going to go over at all, and I'm going to go down 1. I'm going to go right 1 and down 1 for 1, negative 1. And I can make a few more points if I want to there, and I can see that this is going to be a horizontal line. So then I'm going to draw my line. Making sure I've got arrows at both ends. And then I'm looking to see, okay, where do these two cross? Well, they cross at this point right here. So I need to tell what that point is. Again, the graph is not your answer. Your graphing is the way that you get your answer, because your answer is that ordered pair. My ordered pair here on the x-axis is 1, and on the y-axis is negative 1. So my answer is 1, negative 1. Please make sure that you have both lines graphed and the point 1, negative 1 before you move on. We're going to switch back to notebook paper and check this point in both of our equations. Alright, our solution is 1, negative 1. So I'm going to check that in both of my original equations, not after I solved for y, but before. So I'm going to say 2, and this is my x, and this is my y. So 2 times 1 plus negative 1 equals 1. And I check it here. Now on this one, y equals negative 1. Then I only have the y, so it's negative 1 equals negative 1. So I'm going to work this one out. 2 times 1 is 2, plus negative 1 or minus 1. 2 minus 1 is 1, and 1 equals 1, so that one checks out. Over here I just have negative 1 equals negative 1, so that one checks out as well. Again, it has to work for both, so it has to check for both of them. Make sure you have that check down before you move on. All right, go ahead and write down number 5. For number 5, we have 2y equals 3x minus 6, and we have 2x minus y equals 5. Those are our two equations in our system. All right, now again, neither one of these are ready to graph, so I have to get them both into y equals mx plus b first. This first one, to get that y by itself, I just need to move the 2. Since the 2 is right next to it, it means it's being multiplied. So I just need to divide everything by 2. And I get y equals 3 over 2x minus 3. And again, I'm going to leave that as 3 over 2 and not change that to a decimal because it's a slope. We need to know how much to rise and how much to run in a few minutes. This next one takes a little bit more work. We've got to subtract the 2x from both sides to get the y by itself. I'm going to put a 1 in front of this y right here so that I remember to bring it down as a negative 1y. And that equals negative 2x plus 5. And again, I bring that down as a negative 1y because of the minus right here. Then I need to get rid of that negative 1, so I'm going to divide everything in there by a negative 1. So y equals 2x, because negative divided by negative is a positive. And then it's going to be minus 5. So now I'm ready to graph. So we're going to move over to our graph paper. Make sure you have both of those solved for y before you move on. You can pause the video now if you need to. Alright, I found number 5 on my notes sheet, and I've went ahead and wrote down my 2y equals mx plus b equations for my system so that I'm ready to graph. This first one starts at a negative 3, so on the y-axis I'm going to find the negative 3, negative 1, negative 2, negative 3, and put my dot there. And then my rise is 3, and my run is 2, and it's positive, so I'm going to go up 3, 1, 2, 3, and right 2, 1, 2. Now, from where I'm at, I can't go down 3 and left 2, but I can make another point from this point right here. I can go up 3 and over 2 again. 1, 2, 3, over 2. Okay. And for this lesson, you'll probably need to make more than just a couple points. You'll need to go all the way to the end of your graph. Just that way you can make sure that you find the point where they're crossing. So now that I have my points, I'm going to draw my line. Making sure I have arrows at both ends. Whoops. Sorry, there's a lot of movement there. Alright, now I'm ready to graph my second line. My second line starts at negative 5. And I have a slope of 2 over 1. So I'm going to start at negative 5 on the y-axis. Negative 1, negative 2, negative 3, negative 4, negative 5. So right here. And this tells me to rise 2 and run 1, and it's positive, so left to right it should be going up as well. So I'm going to go up 2, 1, 2, and over 1. And again, I'm going to have to keep going to figure out where it is that these two are crossing. So I'm going to go up 1, 2, and over 1 again. I still haven't found it, so I'm going to go up 2 and over 1 again. 1, 2, and over 1. Now it looks like they're going to cross right here, but that line comes close, but it does not go through that point right there. So I'm going to have to go up 2 and over 1 again. There's the point where they're going to cross. It's way up there. So I'm going to go ahead now that I've got my points, and I'm going to draw my line. And again, I have to write my answer as a ordered pair. I'm going to do that right up here at the top. So the x part of this point is 1, 2, 3, 4. So it's going to be 4. The y part of this point right here where they're crossing is going to be 1, 2, 3. So it's the point 4, 3. The point 4, 3 is my solution to this system. Now we need to check it in both equations to make sure that I got the correct point. So we're going to move back over to notebook paper. Make sure you have the two lines graphed and your ordered pair before you move on. Alright, so on number 5, we're going to check the point 4, 3. So this is my x and this is my y, so I'm going to check it in both. And again, I'm going to go back to both originals when I check. So I'm going to go back to the original one here and say 2 times 3 equals 3 times 4 minus 6. And I end up with 6 equals 12 minus 6. Well, 12 minus 6 is 6, so 6 equals 6. So it works for that one. Now we're going to go back to this one, and everywhere I see an x, I'm going to plug in a 4. Everywhere I see a y, I'm going to plug in a 3. So we're going to say 2 times 4 minus 1 times 3 equals 5. Whoops. I can't see that. Hold on just a second. There we go. Alright, so now we're going to say that's 8 minus 3. 8 minus 3 is 5, so 5 equals 5. And it works for that one as well. So again, it has to be a point that works for both or checks in both as well. And it does, so we do have the correct point. Please make sure that you have that entire check written down before you move on. Alright, here's number 6. Go ahead and write it down. This is the last one we're going to do on your video. We will shave 7 and 8 for tomorrow in class. Number 6 is 4x minus 5y equals negative 20, and 2x plus 5y equals negative 10. Now again, neither one of these are ready to be graphed yet because they're not in y equals mx plus b, so that's the first thing we have to do here. Again, my whole point is to get this y right here by itself, so I need to move that 4x. It's a positive 4x, so I'm going to subtract 4x from both sides. This side it's going to cancel. I'm going to have negative 5y equals negative 4x minus 20. Again, can't actually subtract those. 20 doesn't have an x. Then I need to get rid of the negative 5 by dividing everything by negative 5. And I end up with y equals negative divided by negative is a positive 4 over 5x. Negative 20 divided by negative 5 is a positive 4. So now I have this one in y equals mx plus b. So I'm ready to graph on that one. Now we've got to get the other one ready to graph. Here's my y, so we're going to subtract the 2x from both sides. And get 5y equals negative 2x minus 10. Let's get that over so you can see it. Then we need to get the 5, move the 5, so I'm going to divide everything by 5. And we get y equals negative 2 over 5x minus 2. So again, now this one is in y equals mx plus b. And again, we left those as fractions because they're going to tell us how much to rise and how much to run. Now that we have both of them in y equals mx plus b, I'm going to move over to my graph paper. So please make sure that you have all of this written before you move on. If you need to pause the video, feel free to do that. Alright, now I'm ready to graph. On this one I'm going to start at plus 4 on the y-axis since that's the end number or the y-intercept there. So 1, 2, 3, 4. I'm going to put my dot. Then I'm going to look at my slope. It says to rise 4 and run 5. So now I can't go up 4 and over 5 because my graph won't allow me to do that. So I'm going to have to go down 4 and left 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. and put my dot there. And with this graph, I'm only going to have room enough for 2 of those points, so I'm going to go ahead and draw that line. Again, go ahead and put arrows on both ends of that line after you get it drawn. Now I'm going to graph the second one. I'm going to begin at -2 on the y-axis because my -2 right here. So I'm going to start right here. And this tells me to rise -2 and run 5. So I can go down 2 and right 5. 1, 2, 3, 4, 5. Or I can go up 2 and left 5. 1, 2, 1, 2, 3, 4, 5. And now I can see where they're going to meet. Go ahead and draw this other line. Now again, making sure that since this was 4/5, this line left to right is going up. This one was -2/5, so left to right, that one's going down. Again, that's just a good thing to go back and check. So now I'm ready to identify this point right here where they're both meeting or crossing, because that's my answer. Again, graphing is your way to get to your answer to the actual point where they cross. And this one is going to cross at, the x is going to be 1, or -1, -2, -3, -4, -5. And I didn't go up or down any, so that's -5, 0 is my answer to this one. So my answer is the point -5, 0. We're going to go back and check that point into both of our original equations. So I'm going to move back to my notebook paper. Please make sure that you have both of these lines graphed and the point -5, 0 written down before you move on. Okay, so I'm going to check the point -5, 0. So I'm going to go back to this original equation up here before I did anything, and where I see an x, I'm going to plug in a -5. Where I see a y, I'm going to plug in a 0. So we're going to say 4 times -5 minus 5 times 0 equals -20 for that one. And then over here I'm going to say 2 times -5 plus 5 times 0 equals -10. I'm going to scoot this up now that I have them written out so that we can see. Here, 4 times -5 is -20. -5 times 0 is just 0, so this gives me -20 equals -20, and that works out. Here, 2 times -5 is -10. 5 times 0 is just 0, so -10 equals -10. So it checks and works out for both. So I do have the correct point and the correct answer of -5, 0. Again, please make sure that you have that entire check before you move on. Alright, so we've covered our first objective, is to solve systems of linear equations in 2 variables by graphing and classify the system based on the number of solutions. Okay, and we talked about how you could have one point as your answer, or you could have no solution or infinitely many solutions. Okay, tomorrow we're going to look at solving contextual problems and interpreting solutions in context in class. So this is the end of your video. Thank you for watching.